Good morning, champs. So far, we looked at closed systems like a piston, but most real engineering systems are different. Fluid flows through them. Think of turbines, compressors, or pipes. Now, energy does not only enter as heat, it also comes with the flowing fluid. Let's start from the general energy balance. The change of energy inside the system equals heat, work, plus energy that comes in with mass, minus energy that leaves with mass. Now here's something very important. This equation uses total energy. But total energy is made of three parts. Internal energy, which is the energy inside the particles, kinetic energy from motion, and potential energy from height. In most thermodynamics problems, nothing is moving fast and nothing changes height. So we simplify. We say the change of total energy is approximately the change of internal energy. So even in many practical systems, we mainly track internal energy. Now let's look at what happens when fluid flows. Imagine fluid entering a system. To get in, it has to push the fluid that is already inside. That requires energy. So flowing fluid carries energy with it. Not just the energy inside the particles, but also the energy needed to push into the system. To combine these two effects, we introduce a new quantity called enthalpy. Enthalpy is internal energy plus this pushing energy. So you can think of it as energy inside plus energy to make space. This is why we use enthalpy in flow systems. Instead of tracking two separate contributions, we use one single quantity. Now let's look at an important simplification. In many systems, nothing changes over time. This is called steady state. That means the energy inside the system stays constant. So energy going in must equal energy going out. In that case, the equation becomes much simpler. Heat and incoming flow must balance work and outgoing flow. Physically, this means fluid enters with a certain energy, leaves with a different energy, and the difference becomes work or heat. For example, in a turbine, fluid enters with high energy and leaves with lower energy. The difference is converted into mechanical work. So the key idea is simple. We start with total energy, but usually simplify to internal energy. And for flowing systems, we use enthalpy. Because flowing fluid always carries both energy and the ability to push into the system.